Okay, welcome back. Let me repeat what I said before we went for that short break. I said today we are going to concentrate on two areas. First area is what is described as machine learning. Sorry, what is described as data mining. And inside data mining, we may talk something about machine learning. So data mining, and we will conclude it with principles of relational database design. These are the two specific things we're going to waste. I'm going to spend the time on. I earlier sent you information on the principles of relational database design. Did you get it? Okay, so I'm sure everybody got it. If you don't have it now, you should go and get it after the class. I also sent the slide on the data mining, and everybody is supposed to have copy by now. And most importantly, have read through it before this lecture. The essence of me giving you the information ahead of time is for you to read through the information, try to understand it at your level so you can make a meaningful contribution to class, ask meaningful questions to help the class, right? So nobody is here without it. All of us have it. So let me share my screen with you.
And so,
Okay, hello class. Can you see my screen now?
Yes, please.
Yes, sir.
Okay, so
Sir.
Yes, sir. Yes, sir.
this is what we're going to talk about. Data mining, one, and then two, principles of RDBMS. Okay, so this is what I was saying. I'm going to do the first part of this class with this slide. And you already have the slide. Can you see my screen still?
Yes, sir.
Okay, so we're going to talk about data mining. Since you've already
yes, sir.
gone through the data, we will try to be very brief with what we have to talk about this one. Data mining, right, is simply the process of uncovering patterns and other valuable information from large data sets. We've already talked about what big data means and how big data is increasingly getting big, and the importance for businesses, not only businesses, almost all of us, to pay particular attention to big data. We've dealt with all of those stuff. So if you have to pay attention to big data, all that we need to do is to actually get the ways to tap into the benefits of big data. Big data, I told you the other time, as if I was exaggerating. Big data is God, which you can pray to, and then it can answer your questions. At least in a business setting, that's what big data is. So the data mining of the ways is one of the ways you can gain insights and the benefits and all the magic from big data. Please, before I go on, let's try to mute sorry, yes, our cameras and our microphones at the same time. Let's mute them when we join so it doesn't disturb the class. So data mining simply is the process of dissecting the big data to see what is inside it, to see all the things hidden inside, all the magic hidden inside that big data, which is needed for you to be successful as business. Big data is like a magic. It's like a god, like I told you before. So you need to speak to it. You need to kind of query it and get whatever is inside it for your benefit. And now we don't have any option than to go these ways because technology abounds to support actually getting insight from big data. And one of the techniques is data mining. Data mining, let's see what actually it is. I'm not going to teach deep into data mining, but at least we need to get very good understanding of what it is. It's formed through the following broad areas in mathematics and science. Statistics. So data mining is a combination of these techniques to harness the power inside the big data. Statistics is the numeric study of data relationships. This data, that data, all the data, what relationships, what trends can we find that can help us to understand what has happened, what is happening, and what we should do. And apart from statistics, you will see artificial intelligence. Artificial intelligence is human-like intelligence displayed by software or machines. Nowadays, you can see all your machines as very decision-making enabled. They behave like yourself. And that's what we call artificial intelligence. They are not really human beings to be intelligent, but they mimic human beings in so many ways. Softwares that are coming nowadays, machines that are coming nowadays. So that put together is what we call artificial intelligence. Data mining also involves machine learning. Machine learning is simply algorithm, some procedures, mechanisms that can learn from data to make predictions. Okay, so that's what broadly data mining is, which means that, and we learned this in our previous lectures, that a trend in accounting and finance is towards these areas. So that if you don't position yourself very well in these areas, very soon you can never be used for anything. Which means that everything about these areas I said, statistics, you need to ground yourself very well in statistics. And as accounting students, I don't think you have so much problem with quantitatives because statistics is purely quantitatives, numbers and trends, patterns, what the numbers are revealing to us. So we all have to now understand that as accountants, we have to double as statisticians because this is the big deal. Big data and what the data is speaking to us as business, the direction the data is saying we should go. Data is God, which speaks to you. And if these are the things that you can use to make the data speak to you as a business, then you can't afford to say as a business student, you will, you will skip it for whatever reason that you have. No, we can't do that. Okay, let's continue. So diagrammatically, this is what data mining is involved with. You need to get database technology, knowledge, skill. And of course, if you look at the course outline, we'll talk about database. That's why we said relational database management system. In fact, that's the next topic we'll begin. Statistics, like I said, visualization, other disciplines, information science, machine learning. Okay, so broadly speaking, you can even see divisions of these areas into much more specific areas. This is just alerting you to the fact that you should now begin to have your eyes, your senses, everything towards these things. If for most part of your learning, you were not exposed to these things, it doesn't mean that these things are not to be learned. It means that you have not been taught yet, or probably you will never be taught. So if you're found it yourself, teach yourself, kind of thing. So all of you need to know what is actually happening in the world. It's not, most of it is not how you are taught in class, but you as students need to see beyond what is happening in the classroom. The world is not your classroom. Yeah, most of the time we don't teach anything in the classroom, so don't rely on classroom knowledge. So you have to go and know about these areas. Right, let's move forward. Why is data mining important? I've already made mention of some importance in my presentation already, but let's read this slide to be a little bit more specific. Data mining allows you to do at least these things. Sift, and I think we all understand the word sift. Sift through all the chaotic and repetitive noise in your data. When you collect data, and of course, now when we say data, we mean big data. When you have that big data available, some values in that data set may not speak anything. They might even have been captured wrongly, and they don't really give any direction. Maybe I'll give some examples to explain that. You have to get the capacity, the analysis mechanisms to be able to siphon all the data that is not speaking anything. Because if your God is speaking to you and some Satan is also speaking at the same time, you can get confused. So you want to actually sift out, so to say, all the satanic voices, so you can get God's voice truly. Data mining is the knowledge you need to have. And you know what data mining is involved. You need to get all those elements of skills, and then you can do this thing. So you can imagine how important data mining is to businesses. If you can sift out all the data that is not really telling you the truth about what is happening, so that you can have a clear idea about what is happening. Is that not magic? That's one importance of data mining. Understand what is relevant and then make good use of that information to assess likely outcomes. Simply put, what this point is telling us is data mining can help us. It's actually linked up with the first one. It can help you to know the relevant stuff from the irrelevant stuff. Right? That's what it will do, so that you can make better decisions. Accelerate the pace of making informed decisions. So that's what it is. You can get more other importance for data mining, but broadly speaking, these are the key issues in the data mining process. When you read on data mining process, probably you can come up with um, not only one process that you can follow to do your data mining, but we are going to talk about what is called the CRISP framework. CRISP DM. The CRISP stands for cross, the cross is CR. So cross, I for industry, S for standard, and this P for process. Cross industry standard process. And the DM is for data mining. So some people even write a script, the CRISP without the DM, because the CRISP is actually designed for data mining. It's a process designed to do data mining that is judged to produce better outcomes. And let's see what is inside the CRISP DM framework for data mining. A process of 6 steps. Number 1, business understanding. For your data mining project to produce better outcomes, to be successful, since you're doing the data mining on business data and for business decisions, I mean, it is without doubt that to be able to do a good data mining job, you need to get a good understanding of the business.
What just happened?
Wow, how come the how can the meeting person?
Hey, course report is going on, please.
Keep
Boy, I
quiet.
don't even know. I don't even know how come someone presenting just only data.
Course rep, tell us something, I beg you. I'm using my data, I beg you.
Hey, Raf, it's you.
Prince Charles, big time.
Guys,
And then break
please,
time.
please, let's relax. I'm sure Say is having a problem with his internet connectivity, so please let's relax, right? I beg.
Hey, hey, no, it's less than 48 people. Hey,
When I'm over.
Yo, shout out to Kingsley.
Oh, Charlie, my data, I beg you. My data. Oh,
Stop to Reggie
guys,
now.
a subject for Tescon
Charlie,
organizer.
me faithful.
2021. A subject for Tescon organizer.
Hello, guys.
Kingsley, man, I miss you.
And I continue.
oh, you are making noise. You are waiting for the lecture. Please relax.
It's us
Okay,
anyways.
Raf,
Charlie, I'm back. Let me continue.
Raf,
So where were you?
Hey, please, let's wait for the lecturer. Relax.
A subject for Tescon organizer. Hopeful.
Yo, Raf.
Let's continue.
Hey, we are recording
But
the
you
thing.
are
Rap.
We are
using
recording the
the
thing.
recording the one there.
Rhapsody. Rhapsody. Rhapsody.
Yo, my boss.
hey, Raf, to just sir.
I cover Rap.
Uh-huh.
I cover where you know IT once. You dey do all lies there. You know this yet. Wait, your boss IT man is IT edit yet. I'm on. What's up?
Sir, please, my hand is up. I have a question.
The boy.
Please, they are recording the Sir, please, my hand is up. I have a
Guys,
question.
guys, please let's show some respect.
Hello, you guys did this step, Charlie. Oh,
Guys, please let's show some respect. Please, bros, phone. The lecture is recorded.
and right minutes of talkatives.
Please, bros, phone.
Sir, please, my hand is up. I have a
The
question.
lecture is recorded. So whatever you say, you listen. He is recording the video. So please, whatever you say, you listen. Just
Sir, please,
relax.
my hand is up. I have a question.
Just relax. You will come back. Just relax.
What is this now? What
Sir, please, my hand is up. I have a question. You too.
Oh my God.
More like. Hello, sir, please, I have a question.
Please hold on with your question and we will answer you.
Anyway, recording the new.
Oh, sir, please, my question is still pending. No, so I have a question.
Duncan. What make you do you? Which small lecture will come, then go ask a question, eh?
Hello, everyone.
Hello, sir.
I think
Hello,
accidentally
sir.
we lost connectivity to ourselves.
Yes, sir.
Yeah, that's very bad. I don't know if it was a power outage or something. So I want to be sure if we are all connected now.
Yes, sir.
Yes, yes, yes.
Yes, sir.
Get
We are here.
get back
Yeah,
going.
yeah.
Okay.
No, sir.
So who Who can give me a summary of the last thing I was trying to explain before the link went off? So I know where to start from.
So please, we are talking about the data mining process.
I was talking
Business
about what?
data mining process, and you were a business understanding.
Okay, sorry for that. So let me go back to the. Okay, so this is the data mining process according to the CRISP DM framework. I think I've already explained what a CRISP DM framework is. It involves 6 steps. 1, business understanding. I've already explained it. Data understanding. Data preparation is if you have understood the data, you need to actually group the data according to at least the levels that you measure the data. Some data may be categorical in nature. Others may be on interval ratio levels. Others may be other things. You need to prepare the data around all these dimensions that support the kind of modeling you want to do. Then the next step, which is step 4, is actually modeling the data to see what the data is speaking. You normally come up with some model that you can always run for the data to predict something for you. When you do that, you have to evaluate how strong that model is. So that's the 5th phase or step, which is evaluation. And the last one is deployment. If everything is okay, you go and just do implementation. When you go through the slide, okay, so this is a diagrammatic explanation or representation of what we just saw. So this is the data. When you go through these processes, through the data, you'll be able to get a lot of insights into the data, which will give you direction as a business where to go, where not to go, so that you can be successful. That's the idea. The following slides explain the phases or the 6 steps in some detail. And you already have the slide. I've explained them. So I don't need to repeat that thing. So you can go through them later by yourselves. So business understanding, data understanding, modeling, evaluation, deployment. You can know some specific stuff inside there. Okay. Any questions about what we've said so far before I start talking about data mining techniques? Yes, class, I need to hear you. Any questions so far? Any questions? Okay, so no response tells me there is no question. That's good. So let's talk about data mining techniques. We need to first understand the broad idea behind data mining. Just a process that you want to use to actually dissect your data to see the intestines, the small one, the big ones, the veins, the small one, the big ones, everything inside the data, so that you can know, you can get that information to support your decision making. Broadly speaking, that's the idea behind data mining. So if that's the idea, then we can even begin to understand some of the techniques that we can employ to do that. But here are some specific things about data mining techniques. These are what generally happens inside data mining. Cluster analysis. And we said earlier that data mining is underpinned seriously by statistics, machine learning, and other stuff. So you should now begin to see the power of statistics. And by this, you should now begin to understand that the era where you could say, okay, me, I'm an accountant, give it to the statistician. He did statistics. That era is dying out. It has already died out. And as an accountant, you have to be everything as far as dealing with numbers, because business data is numbers. Okay, so cluster analysis, one technique that is used inside data mining. What does it involve? Cluster. What it does is that big data set, it tries to read the data and group the data into families based on their likeness. So it's like if we have a group of people mixed up and you want to actually read them either by looking at the way they speak plus other things into their ethnic groups, Ashanti, Ewe, blah, blah, blah. That sort of work is what cluster analysis does. It kind of does employ its algorithms, all that, the kind of techniques it uses, and is able to group that large data set into some clusters or families, so to speak, based on their characteristics. So kind of forming them into families of data. At least this technique alone provides a lot of opportunities for businesses. When you do cluster, okay, let me ask, how can we employ cluster analysis for business decision, given the understanding that we have now about what cluster analysis is? It's a question for debating, for discussing. It's a question. Are you here with me? I don't hear anybody's voice.
Yes, sir, we are here.
So respond to the question.
Sir, please, the question again.
The question is, the way cluster analysis works, how can we use it in business to do better decision making? I've already explained what cluster analysis is. So if the class is here with me, they should have that understanding. And based on that explanation I gave about what cluster analysis is, I'm asking that how can we use what cluster analysis does? How can we use that thing in business? You now get my question.
Yes, sir.
No.
Okay, so who wants to respond? You mentioned your name, and you actually respond.
Hello.
You remember I said part of your continuous assessment goes for class contribution.
Hello.
So I'll be tracking all those things. So if you want to
Hello.
answer, mention your name to the whole group and then go ahead. Alhaji Abbas. Alhaji Abbas.
Hello.
Alhaji. Is Alhaji Abbas in class?
Hello.
Alhaji Abbas, are you in class? Okay, absent. I've indicated that. Bright Osibo. Bright Osibo. Bright.
Sir.
Are you in class?
Hello.
Respond to the question.
Please, I just joined.
Hello, sir.
Yeah, Nicholas. Nicholas, you raised your hand. Nicholas, you raised your hand. Just talk. Erica Jima, are you in class? Bright, if you are ready now, you can speak. I can see your hand is up. Are you just raising your hand for fun? Nicholas, your hand is up.
Hello.
Yes, talk.
Sir, please you say Josiah.
Talk, you can talk, even though I didn't say that. Talk.
I was asking, did you say Josiah? Did you mention the name Josiah?
Yes. So answer the question.
Okay, with the cluster, okay. It helps businesses to cut down their cost. In the sense that when you get to know those who patronize your goods, you spend less advertisements on them, and you invest more on those that the target market where you want to expand to.
But how will you be able to, first of all, get the idea of your target market and your customers as you are speaking? How will the cluster analysis help you get that? That's how we want to understand it. Okay, because of the way cluster analysis works, it can be used to do this, which can be used for this and that and that. Make your explanation flow in that order.
Okay. We get to relate our target market, the revenue. You get to relate it. You get to arrange them by revenue basis. If at market A, market B, market C, and their revenue differs, let's take the 100, 50, and 20. We get to know that target A is our best market. Market A is our best market. So if you are to advertise or you are to spread our wings or you want to expand our territory, we invest more of advertisement in market B or market C.
Okay, I think you are right. It's just that I need to add something to it for them to see the connection. You understand what you are speaking. I can clearly see that. But I don't think the people can understand it like the way you are understanding it. What he's trying to say is that we say cluster analysis is a technique that you can use to actually group form groups from a big data. What I'm trying to say is that as if you run that technique through the big data, it is able to see that, okay, this data belongs here, this belongs here. So we'll be grouping them to form families or different groups we call clusters. That's the main thing cluster analysis does. So if that's what it does, then we can clearly see the opportunities it provides in businesses. In businesses, we want to know, like he said, we want to segment our markets in terms of many things. What he was speaking about is probably in terms of revenue that they bring. So if we have that data about all our customers, and cluster analysis can group them into high money generating markets, medium money generating markets, small money generating, and so on and so forth, then that's a very good thing. Then, like he said, we can know what to do. Who are those disturbing the class? Nicholas.
Sir.
Nicholas.
Sir.
Should I leave the lecture? Are you the one that they are speaking through? I can hear
Yes,
a
sir.
lot of noise.
Sorry.
Okay, so what he said is very good. So now I have tried to open it up for you to get exactly what he meant. We can use cluster analysis to organize the database we have on our customers into high revenue generating customers medium, small, if you like it that way, or in some other way that supports our business. We can also use cluster analysis to actually okay, he talked about revenue. We can do it for customers. So we serve a very big market. We can segment our customers into different things, into their preferences, so that we can know that, okay, this is maybe children wear stuff. This is how this market is doing. We can segment it into these different markets on product lines and later learn the statistics over there. So it can be used for any cluster, any grouping things, which can give us a lot of insight for decision making. Right, let's go ahead. Another technique for data mining is regression, and regression is very much familiar to you. Not this one, not so much, but regression is very familiar to you. Have you done quantitative methods?
Yes, please.
Or what is it even
Sure,
called now?
sure, sure.
Business. They call it a different
Yeah.
name now. What's the name you call it now?
Quantitative methods too.
Okay, quantitative methods, right? So I think
Quanti.
through quantitative methods, you learn something about regression, isn't it?
Yes, sir.
Yes.
Okay. So let me just talk about it and then we can move forward. Regression is simply trying to predict the behavior of some variable by getting information from some other variables. So you talk mainly about what we call independent variables, dependent variable. The idea is that in the world, which is structured on the law of cause and effect. Cause and effect. Have you heard of that law before? I mean, from psychology. Law of
Yes.
cause and effect. Who has heard of it before? Who has heard of it before? Let's hear you. The law of cause and effect. Okay, because you think I'll call someone, nobody has heard of it. Richard, you've heard of it. Richard,
Say,
your hand is up, you can talk.
yes, please, I've heard of it.
Can you give us the gist of it?
What I remember is something happened based on another thing.
Okay,
A situation occurred based on something.
that's good. That's true. The law of cause and effect is simply saying that everything that you experience, every effect. So we can give an example of an effect. You are sad. You are poor. You are whatever. Any of these things has root causes. Causes produce effects. Effects have causes. And I don't think that idea is wrong. It's 100% correct. That's how our universe is structured, cause and effect. So regression tries to actually let us know that pattern, which were the causes of which. How does these causes produce this effect? Or what effects do these causes produce? They're all coming from the law of cause and effect. And that's what regression can help us to understand. This thing, what is causing it? or which things are causing it. That's what regression will do for us. And you can immediately identify the value of this technique for business. Because in business, we want to understand what causes this, which is likely to cause this, and how can we control the cause to get or maximize, augment the cause to get more effect, and so on and so forth. We do a lot of those things in business. So if there's a technique that can make us do that, why wouldn't us fall in love with our technique? So like what I asked about cluster analysis, how can we use what regression does in business? How can we use it in business? This time around, it's not about who wants to talk. It's about who I want the person to talk. Okay, so which person I want to respond to this question is Sandra Tavia. Sandra, are you in class? Yeah, Prince, I've seen your hand. Ima, your hand is up, but I want to give the opportunity first to Sandra. Sandra. Sandra Tavia.
Yes, sir.
Yes, please respond to the question.
Sir, please, I have no idea.
Oh, I gave you the idea. Did you hear what we said about regression?
Not really.
Why? What were you doing?
Please, the network is poor here, so the line keeps
But
on
we
breaking.
can get a very free flow of conversation, which means you should clearly hear whatever I'm saying. No problem. Prince, you have your hand still up. Say something.
Say,
Yeah.
you can use regression to
Prince, can you
predict
speak out a little
future
bit so that your friends can hear you?
You can use regression to actually predict future sales. That is for businesses.
Good. Good.
Also for telecommunication businesses like MTN, for instance, they can use it to know the relationship or the linear relationship between the waiting times of callers and also the number of people who complain about their services.
That's correct, Prince. 100%. So let me
Thank
expand
you.
what Prince has said a little bit about predicting sales. You just heard me explain regression as doing the job of cause and effect. If the law is cause and effect world, and that something causes something, there is nothing that is existing without a cause of it. What regression does is that it helps us to know, okay, this particular thing, which things caused it? Thing A, thing B, thing C, thing D, or which other things cause this? The reverse can also be done. This thing, what causes can we trace it to? And these causes, what effects do they produce? That's what regression through the law of cause and effect is helping us to understand. So how we can borrow that idea into what happens in business is that in business, you will have sales data, and you will have data on many things that cause sales to occur. So you can gather all these data sets. For example, you may think that, okay, advertising cause sales to occur. Some other things cause sales to occur. Income levels of consumers, the general strength in the economy, blah, blah, blah. So much things can influence our sales. So you gather all these data, and then you want to actually know how the cause and effect relationship is established between them. Yes, and that's regression. The second thing he said is that apart from wanting to know from other variables how your sales will be doing or which variables are causing your sales, you may also want to know how some other things, like he made mention of customers' complaints against waiting time. You can even establish it between some other variables. You want to know the relationship between the level of complaint by our customers and the level of time they spend before they get their problems fixed. Clearly, you can see that there'll be a relationship. They will be moving in the same direction. But the regression will help you to establish that specific linkage of cause and effect. Okay, is that okay? Any question before I move on? Okay, silence means no problem. So you can read through the details on the regression. Then there's another technique called classification analysis. So classification analysis is quite similar to cluster analysis. They all try to form groups. But here, the key difference is that this kind of analysis is a little bit guided than cluster analysis. Cluster analysis, the raw data set is there, and the technique is now just going to learn how to group them based on their characteristics. The classification analysis, the analyst himself will have an idea of the groups that he wants the data to fall in. And then he organizes the data into those containers, those groupings he himself has set up. That's the key difference between the two. There's another technique called anomaly or outlier detection. Data mining can help you to know that, okay, data follows this pattern only for this unusual pattern to be exposed. As it can tell you, that is the general trend. So this is a very abnormal behavior in the way the data is behaving. That means something fishy, something unusual is at that spot, which requires our investigation. So this technique, how can we use this technique? Who can give us some information about how we can use this technique in business? Then we pick it up and move forward. Yeah, Iman.
Light on the anomaly. It's not really clear.
Iman, your voice is very low. Can you speak out?
I was just saying that with anomaly, I'm not really clear that you can throw more light on it.
Okay, I'll go over it, but I think someone can be a little bit clearer. Let that person respond to the question. How can we use the outlier detection, anomaly or outlier detection technique of data mining in business? How can we use it in business? Hastings. Yeah, Hastings.
Please, I was trying to ask question. I wanted to ask question about the difference between the cluster and the classification analysis. I want you to
go over it.
The difference between the classification analysis and the cluster analysis.
I'll go over it.
The difference.
No problem about that. But I want you to respond to my question of how we can employ the benefits of anomaly or outlier detection as a technique of data mining. I've explained how it works. So how can we employ how it works in business to gain some benefits? Yes, who wants to respond to that question?
Sir, please, I would like to ask.
Yeah, yes,
Can
please.
you
Yeah,
say
Rita.
that?
Yeah, Rita,
Sir,
please
please,
go
can
ahead.
you say? Sir, please, can you say that the information you've kept or the data you have made, if you make a mistake, you can use this to correct it, or this one helps you to detect that mistake or error.
Yeah, of course. Of course. What we can get from what she's saying is that if this is the general behavior of the data, then at a point, some unusual behavior, what she wants to say is that that could represent an error, which we can now target and correct. Yes, but it is more in general terms. We want some specific cases in business that we can use this for. Oh, okay. So let me give one. One big use is in the security areas, like those who do criminal investigations, fraud detection, and forensic accounting, forensic auditing is also about that. So it's not too far from business. Those people employ this technique a lot. For example, if they want to subject your accounts under the checks of money laundering, and money launderers do the activities in some way that produces a pattern that they can use this to detect. One other use is that in business, fraud can occur. It depends on the nature of the business. Big time fraud can occur. Okay, so these techniques can be employed to interrogate data. It will show the general trend of the data. And if something unusual has happened, the data movement will show some different direction from the normal direction. That's the outlier. And that can tell you that maybe fraud, because it's something unusual, something that doesn't really follow the pattern of our business. And that could be fraud, which can be just tracked, investigated. Okay. You can find some more other examples. So the last one I'll talk about is association rule learning. Not too different from the law of cause and effects and regression. So once now, for example, your cluster analysis or your classification techniques have helped you to group the data. The data groupings may be called variables. So this, you have different variables in the data set. Cluster analysis can help you do those groupings. Then you may want to know how each
Stop there. What is my blood?
each of the groupings, each of
It's
the
like you look
variables
like
are relating to themselves. It is similar in fashion to regression, but slightly different. So we can get deep into associative learning, associative rule learning, and regression to know the clear difference between them. So this is what I think For the time being, we need to learn about data mining. Data mining, what it is, and the notable techniques. That's very important for us. Any questions? And then I close the chapter on this so we can do something small on principles of relational database management. Any questions? Questions? Okay, so if there are no questions, then we can go to our next area. We need to spend a few minutes on this, then we can go, we're already home, then we can find something else to do. Principles of relational database design. Okay. In relational database designs, data is housed in tables. So if the building blocks of databases is tables. I mean, for structured data, it's tables. So what the RDBMS principles, or what the relational database principles primarily is talking about, is how you structure your tables. But why do we have to care about how we structure our tables? You remember the other time we talked about anomalies that we can find in the traditional data management systems. Traditional data management systems. We talked about update anomaly. When you want to update the data, it is very challenging. We also talked about delete anomaly. When you delete data, sometimes it is deleted halfway and we get a lot of orphaned data. So those kind of challenges should be removed so that we get a very good structure for data that supports all the deep kind of learning we want to do. So that's the key idea behind the principles, how we structure the data to remove all the challenges with the traditional data management systems. So let's run ourselves through the principles. The principles of table design. In this case, we can be specific. Table design is to produce high-level database management system, which can support all the kind of analysis that we want to do. Remember, we are talking about big data, and this way of managing your data is going to support that big data keeping agenda and big data analysis agenda. So that's why this thing is very important. That principles are actually done, or they are applied in I think about 5, but we'll talk about 3 main ones. So let me say three main principles. So the principles can be grouped in 3 main principles. Let's put it that way. And those 3 specific principles are normally referred to as normal forms. Normal forms. The reason why they are called normal forms is because when you actually structure the tables to support a big data agenda, when you do that, we say your table is normalized. It's normalized. So a table that is not structured to support this new way or this new science of data management, we say that table is not normalized. The other time, I wanted us to get that practical understanding by calling one of you to demonstrate how he will keep data on a school system. And then see the way he structured the table. That was an unnormalized table. And in RDBMS, the tables need to be very normalized. So we go through the normalization process through 3 forms. And those 3 forms will expose the principles. So let me put it this way. I think this way of putting it is a little confusing. So applying the principles will lead to getting our tables normalized. So let me say normalization. And we do the normalization, this thing is too big. We do the normalization through three main ways. There are other things above the 3, but we'll concentrate on the 3. 3 main ways of normalization, and we call them normal forms. So we have first normal form, that is actually saying first step of the normalization process. So first normal form, we have second normal form, and like I said, we will rest with third normal form, but there are other normal forms beyond the third one. Okay. So we want to structure our tables the best way to support the big data management agenda, which means the tables need to be normalized. We normalize the tables through 3 normal forms, through 3 procedures, and the procedures are called normal forms. So first normal form, second normal form, third normal form. In fact, first normal form is mostly written in short as 1NF. 1NF. This one is 2NF, and this is 3NF, and so on and so forth. Okay, so we'll be talking specifically about first normal form and second normal form. If you're not able to, if you don't have so much time after talking about these 2, we'll talk about the third one later. So what is first normal form saying? So table is rows and columns, isn't it? And we are saying we have to structure this table so that it will adhere to the principles of relational database management. And when it is done that way, it supports the business in managing big data, which is like the magic that can direct the company. That's it. So in structuring this table, what is first normal form saying we should do towards the path of normalization? It's saying we should, first of all, have one of the columns. So these are the columns. So column 1, column 2, column 3, column 4. We should have one of the columns doing the job of unique identifier. So at least one or a combination of the columns should have values that uniquely identifies the records. These are the records. If this is about student records, so this is one student. This is another student. and this is another student. So when we are keeping the data on the students, there should be at least one column whose values are different from each other. Which values make a student different from each other? And that column is called primary key. So let me do a more realistic table for you to understand. I have some tables in the text I gave you that are quite very practical for you to understand. Let's say we have this is student table. And we have these columns. Registration number, first name, last name, gender, date of birth, etc. Let's say we have this table. The first principle we are talking about inside first normal form is that one of these columns, either registration number, FN, LN, gender, DOB, one of them should produce values that uniquely identifies the records, the students in the student table. And if you look at this practical case, the student registration number can do that job. By design, no two students have the same registration number. But two students can have the same first name, the same last name, the same gender, and the same date of birth. They can have all of these things same, but they can never have the same registration number. So, because the values here provide unique identification, it can be assigned as the primary key. Or we can have, the databases normally have their own ways of producing some auto-generated numbers that are unique. We can also do one of those things to produce unique numbers to serve as a column that provides unique identification for all the records. So if it is something, we normally call those generic ones ID. So it can be just 1, 2, 3, 4, because numbers don't end. 5, 6. Student 1 can be student 1 and student 2. They can have the same first name, last name, gender, date of birth, but they are not the same by ID. Student 1 is ID 1, student 2 is ID 2. So at least in the table, there is one record, one column, one field that is uniquely identifying all the students. That's what we call primary key. So that thing must be there. So it means that from today going, anytime you are preparing data, most especially business data, you should always be doing it like this. You should have an ID. The ID, you normally see some of these things in the form of SN, serial number. Yes, serial numbers, and normally it can be 1, 2, 3, 4, 5, or some other numbers that are unique. That's what we are talking about. You have to have that idea. Okay, second, apart from the idea of primary key, second, we are saying that each column or each field should contain atomic values. Each field or each column should contain atomic values. We can get an understanding of what atomic value is by understanding what atom is. And that one, I think everybody is okay. So what is an atom?
For read your mind. Yes.
Yes, if you want to talk, please mention your name and go ahead. What is an atom? Lawrence. What is an atom?
Sir, please, is the smallest particle of an
It is what?
element. The smallest particle
Smallest
of an element.
smallest particle of an
element.
yeah, Mary. Mary had
Please,
something.
the ability to subdivide an attribute.
Okay. What again? Samson. Koku Samson. Yeah, Samson, your hand is up. Talk. Okay, so an atom is like the basic unit of, like he said, of a matter that is beyond splitting. For example, maybe an example will help us. Those technical definitions, they don't help. If you take the human body, they say our makeup is into some levels. They have cell, then cells collect together to form tissues. I don't know if I'm even speaking it right because I read my science books very long ago.
Yeah.
Cells form
Yes,
into
please.
tissues, right? And tissues form into
Yes.
organs, and organs form into systems. So you see that clustering. So the basic thing that form themselves together, that basic particles that you can't divide again, that's what we call atom. So in the human system, the atomic component of our structure will be the cell, right? Will be the cell. Because I don't know how scientists have been able to tell us the components of cell. They can only tell us the cell structure, but cell is not made up of other parts that they have to show. Cell is cell, but tissues can be spread out into the cells that make up the tissue. That's the idea. So let's go back to what we are trying to demonstrate. That's the idea. So this table you see here is saying that each column, ID, registration number, first name, last name, gender, date of birth, should contain the values that will be captured under registration number for all the students, the values that will be captured under first name for all the students. There should be values that should not be compound values. There should be values that are not naturally divisible into parts. That's what the principle of atomicity of column values means. So if you have a table, in the write-up I gave you, see nice demonstrations. If you have a table like, so if you have that thing with you, you can even follow, like table 1. Table 1 is something like this. So it's a student table with 3 columns. So this is student ID, written this way. And then we have student name. Student name. And let's say other attributes. So we have ID 1, and the name is Josh Ado. The next second record is Nana Ajua Sampa. Okay. So you see, this table violates the principle of atomicity, which first normal form is actually requiring. Because under the student name column, the second column, the values here, the values in each for each of the records can be naturally divided into parts. For example, the Josh Ado can be separated into first and surnames, for example. And these are they are naturally existing as discrete components. So when we store it like this, we have not achieved atomicity. So RDBMS requires you to normalize the table by making the columns hold only single data, atomic data. So what we will do with this is that we split this column that we have called student name into first name, maybe last name. We split them for each of the columns. Is that okay?
Yes, please.
Okay,
Yes.
thank you
Yes, sir.
for understanding. Then another principle inside first normal form. So we've talked about two things for now, all under first normal form. First one is primary key, a column that uniquely identifies all records. Second one is atomic values for under each column. And the third one is there should be no repeating groups of columns. No repeating groups of columns. And this is how repeating groups of columns may appear. So we have stored, let me go back if I can use this one. We have stored, let's say we have normalized up to the second thing we did in first normal form. So we have this table. Student ID. Then we have first name. And let me use the opportunity to talk about this because when you keep your big data, you'll be employing a lot of programming because all the techniques that we are talking about, cluster analysis, all those things, they are programming. You have to learn some programming codes. You have to understand some languages that you can use to interrogate the data. So for the ease of programming, we normally don't write with spaces. So naturally we'll write first space name. No. We have to write it as one. It just speeds up programming. In other words, computers don't like spaces, or they don't like spaces in that way, right? So you can use underscore to separate something that has two parts. So the first one we did, which we said it was wrong, this one. So instead of writing student and then name with space, we could have write student underscore name. So the underscore that comes in between them removes the space, and it's like one word, but you can see it's clearly as two words. Others use what is called camel casing. So it will be written as, this is student, right? Because you don't want space, you have to add the name to this to make it one word. So what you can do is that you begin the next one with also cap. So the first word began with capital, that is student. It ended with a small letter. And the next one begins with capital. So it behaves something like, it goes down and then it comes up like this. I think Camel have something like this at the back. Is that true?
Yes, sir.
Yeah, so that's probably the reason why they call it camel casing. This is the spelling. Camel casing. Camel case or camel casing, because I'm kind of thinking about a process. So you can do it like that, but the programming world is, I mean, the most popular thing they do is the underscore thing. So you can actually also be traditional and follow that trend. All right, so let's come here. So now let's say we have done student. So we want to write the programmer's way. So first underscore name, and then we have last underscore name. And we know why we are writing it like this. Then you have something like you want to store phone number, so phone. And then you realize that, oh, the person has 2 numbers, even 3 numbers. And sometimes you can't reach him on this one unless this one. So there's the need for you to keep all of them. So you do phone 1, then you come and do phone 2, another column, phone 3, another column. Phone 1, another column, phone 2, another column, phone 3, another column is what we call repeating groups of columns. Actually, it is doing the same thing of keeping information on phone, but it is repeating itself across columns. That is actually not allowed in relational database design. So if you look at the write-up right now, everybody has a copy. You see table 3, we have first name, surname, phone 1, phone 2. Phone 1, phone 2 is repeating. If we have a policy of storing only one phone number, then we can have only one column for phone, which is phone. That's okay. But once you're going to have phone and the same phone repeat in another column, the same phone repeats in another column, that's frowned upon in relational database design. You know how some people try to, as if they know about this as a violation. So as if they want to trick the principal. This is what they do. They'll write phone 1, one column. Okay, you said you don't want repeating columns of the same thing. Okay, now I have one column. But this is how I'll keep the data. 0208537 semicolon 024556665 semicolon 026894534. Yes, so it's kind of delimiting, separating the values by semicolons, or some will also use slashes. Yes, that's the way you might think. You have to trick that principle of not doing repeating columns. But this is equally frowned upon. If there should be no repeating columns, then there should be no composite values under the column. There should be no multiple values. For each single record, the value under each that it intersects with each field or column should be 1. So if this is for Kofi Ado, what we store for Kofi Ado under phone should be just a single value. It shouldn't be 0208857345 semicolon 0246516635 semicolon 027. No, it should be one value. It shouldn't be multiple values separated by semicolon or something else. That is what we mean by no repeating columns and no multiple values. So if you have something like this, where you have student ID, let's say first name, last name, phone 1, phone 2, and sometimes you might even have email. Okay, instead of phone 1, phone 2, you might have phone, email, and other things. what you have to do to resolve this anomaly of repeating columns is that
What's the
you
class
can cut all the repeating column and form the repeating column into its own table. Because when you see phone 1, phone 2, phone 3 email, it's communicating the idea of contact. So you can cut this whole thing off and form another table called contact, which can have its own ID, contact ID, because there should be a unique identifier. But you can have phone and then have email, and then you can even have other contact things. When you do it like this, because each record is a contact, you can have one, some number here, some email here, two, another number here. This number can be for the same person, these two numbers. All right, but you are not keeping it under, you are not keeping it together for one person. They are separate records. That's the idea. So you can keep as many numbers as possible for any person. And when you do it this way, we link the contact table to the student table. Yes, because that's the main thing we do in relational database. Relation. So tables are related to themselves, to talk to themselves. Okay, any questions so far on primary key, on atomic values, on no repeating columns, and no multiple values? Any questions on them? Hello, any question?
No, please.
Okay, then let's move to second normal form. So we've talked about third normal form stuff. Sorry, first normal form. First normal form. And we basically talked about three things. Primary key, no repeating columns. Repeating columns, and no multiple values. All of these things are under first normal form. Second normal form. Second normal form. What is he saying? Before a table can get into second normal form, it must first be in first normal form. So it's a process. You cannot just jump and start from the middle. Before you can even do the middle things, the earlier things must have been done. So we assume we are in first normal form. So what does second normal form entail? In fact, second normal form actually is the normal form that clearly communicates the main ideology of relational database. Make each table store data on one issue. Make each table a single purpose table. Make it store data on a single, or store data for a single purpose. Don't let one table, store data for multiple purposes. And that's what second normal form is now demanding. It's like first normal form made a preparation for the actual ideology behind relational database. Tables should be storing entity-specific data. So if we have something like this, I think I should have even opened the slide or that kind of information. Okay. Okay, so you can all see those tables. I think that would be good. So second normal form, we must be in first normal form, and each table should be structured in such a way that it stores
Sir, please, we have
only.
the slides.
You have this information.
No, please.
No, this information is there. I posted it even ahead of this.
Okay.
Yeah, so go and get it or find it from those who have it. Okay.
Please, someone should send it.
Hello? So it's saying that if you have something like it, I intentionally put this table here to demonstrate the idea of a table not being single purpose. You see, we have student ID, first name, surname, then we have residence, we have program. And we all know that naturally, students and the residence that they live in and the programs they are reading are discrete variables. They are different stuff. Student is not the same as the resident. The student can even vacate and go home and the resident is there. Yes, student is discrete from program. But when we store our data like this, then we are kind of merging these discrete things into one thing. And this is what we say that the table is not single purpose table. It's multiple purpose. It's kind of storing data on students for student-based decisions, residents for residence, staff, and program. So second normal form requires that always make your table be structured such that one table contains information for one single purpose. So here, we should have a table that stores student-specific data. We should have another table that stores residence-specific data. Another table that stores program-specific data. You don't have to merge them like this. And that's what happened when we first wanted to design some data management system to manage a school. Because we all have the ideologies of the flat file system, all the things we were creating were around these things. And this is a huge violation in second normal form. So we resolve it by what I just said. Break this table into tables that store information about these discrete things. Students is different from residents, different from program. Yeah. So when you resolve this, this is what you might come to have. You might come to, I don't know if, no, I didn't do it. You might come to have different tables, three main tables: students, residents, and program. So by structure, it will be like this. Let me go to my board. So I have to update the notes. It will become something like this: student, another table, residence, another table, program. And then we will have, here we have student as one field or column. We will have first name, last name, gender, registration number, etc. All of them are very specific to the student. It's in connection with the student. Then when we come to residence, we can have residence ID, we can have residence name, we can have phone, and this one, you can put this phone here if it is only one phone. if you want to store multiple forms, then you will violate first normal form, where we have to achieve atomicity and we have to avoid repeating columns and multiple values. If it is one form, fine, you can put it here. And some other stuff specific to the residents. When it comes to the program, we can have progit for program ID. We can have program name. We can have other things that we think is very much specific to program. So these are the columns. And because we can always make the tables talk to themselves, this is never a problem. That's the main power relational database gives you. Any questions about second normal form? Hello, let me hear you. Any questions about second normal form?
No, sir.
Okay.
For now.
Is that not for now? So later you will have problem. Eh?
Yes.
Yes, boss.
So please,
I mean,
we are talking about the first name and then the surname. What about if the person has other names?
so you just bring that as a different column. All that we are saying is that don't store first name and second name together.
Okay.
Yeah, so if the person has other name, you bring it as a separate column. So long as it's not combined into that thing. So just get to understand the principles, then you'll be fine. So let's talk about third normal form, because we
Thank
will
you,
normalize
boss.
up to third normal form. Third normal form. What is it saying? Before we can begin anything about third normal form, we have to first be in second normal form, which also requires we should have been in first normal form. So the idea is that we have achieved first normal form, second normal form, and we are building on the normalization process. What's third normal form saying? Third normal form is saying that, well, if you have a table, let me draw a table to explain. So you have something like this. Student ID, first name, surname, gender, registration number. If you have a table like this, we are saying that all of these attributes, all of these columns are actually specifically defining students. Not something else. That's what second normal form is actually stressing. For example, if you are asked to describe a human being, describe how a human being looks like, a typical human being, then you begin by saying head. That's correct. Hand, leg, wings. What's wrong with this description? What's wrong? What is wrong with this description?
Wings.
Wings. What makes it wrong?
Please, it is abnormal.
Yeah, it's because humans naturally. Who is disturbing us? Please, we beg you. If you want to leave the lecture, you can peacefully leave. That description, the abnormality of a description is wing or wings. Human beings naturally do not have wings. It's the same idea we are communicating about tables storing data for specific purpose, a single purpose. So if the data is for students, if the table is for students, all the columns, all the attributes that we capture about the student, should be describing the student, so that the description should not be like the way I did the human being description: head, hands, legs, wings. No, the wings is not really a description of human being. So the first one we saw, what made it not normalized according to second normal form is you having, where's the one that I had programmed? No, it was this. Okay. So you are describing a student. You say, okay, student ID. Yes, student ID is a description of student. First name, good. Surname, then residence. It's as if you said head, leg, hands, and then wings. So this behaves like wings. This one is behaving like that. Wings. And then you said another thing. Tail. So this program is also behaving like you said tail about describing a human being. And human beings don't have tails. So let the description cover, let it be for only students. And if you want to describe tail as tail, not in addition to something else. If you want to describe something else, another thing, let it be specific about that thing. That's all second normal form is saying. But third normal form is, it kind of picked something from second, it saw something from second normal form. That if you don't take care, we might think we have achieved it all, but something is lacking. Sometimes we can have all the, in fact, this thing, in terms of terminology, so let me do that kind of thing. These other columns or attributes that are not the primary key, we call them non-key attributes. And this is the key, this is the key attribute. So in database terminologies, you say that to achieve second normal form, all the non-key attributes should be 100% dependent on the primary key. What it means is that these things should be describing, it's like the whole table is represented by this student ID. That's the key. So all these things should be dependent on the key. It means that all these things should be describing students. But sometimes we can get some non-key attribute which is describing the student, or which is dependent on the ID through another non-key attribute. And that will not be 100% an achievement of second normal form, because we say second normal form, all the non-key attributes should be full dependency, fully dependent on the primary key. So if some other non-key is dependent on the primary key through another non-key, that's not full dependency, that's partial dependency. So third normal form says we should remove any partial dependency. Let me go to your text and see a demonstration to show you. Okay, so if you see this, we have date of birth and we have age. Yes, a student has name. If you say first name as a description of student, that's not wrong. A student has surname, so this is a description of student. A student has date of birth, so it's a description of student. A student has age, but I see that this age is depending on this primary key through date of birth, because we can know a specific student's age through this. So this thing, because, sorry, Because date of birth and age are related, it doesn't make any one of them fully dependent on the primary key on its own without the other. And that's what partial dependency is. So for us to achieve full dependency, all things causing partial dependencies should be removed. So if this can be gotten through this, it means we can simply remove the age, or we can store the age without this. Let's see if I have some other ways we can demonstrate the partial or the transitive dependency. If you look at this data, this is employee ID, some data on employees, employee first name. So you can also learn about how some people also create the labels for their columns. Instead of just saying employee ID, then first name, surname, because there could be other tables that have surname, first name. So he wants to be very categorical from the beginning. Sorry. By adding this description, MF name, employee first name, employee surname, employee postcode, employees region, employees city, employees district. I think the problem has to do with this postcode and region. You know, we can know your region through your postcode, because most of the codes have codes for region, so you can clearly know immediately you say the code, they know the region you are coming from. So these things depend on themselves before they depend on the primary key. So one is dependent on the primary key through another. We can get to know the employee region through the code. So the employee region is dependent on the employee ID through the employee code. So this is creating a transitive dependency which needs to be removed. That's what third normal form is saying. Okay, and these are the key principles of normalization, and therefore key principles of relational database tables design. Any questions, comments, whatever, before we bring our meeting to a close? Yes, please. Any questions?
Yeah, sir.
Yes, go ahead, please.
Sir, mine is actually on the second normal.
Emmanuel, you have to speak out or we can't hear you. Emmanuel, your voice is very far away. I can hardly hear you.
All right, the table where we have the sir. Okay, I'll speak out. I was asking about the table where we have the resident and the program where you said it's not describing the student. I really do not understand that because all these things are about the student. For example, the parents come to this school and this child.
Hello, Emma. I think you can reserve your question so that we can hear you in class, because I can hear nothing. I don't know if someone hears him who can do the relay. I can hardly hear him.
Hello.
Yes, please.
Oh.
Hello.
All right. What about this one? Hello. Hello,
This
sir.
one is okay. Yes, please.
Hello. All right. I was asking about where you were saying that some information actually where you were using the table where we have the residents and the program, and they were not talking about the student actually. I think if you can use another example to explain, because I can see that residents and program, for instance, could one way or the other describe a student on campus? Because in a way, so if you can use another example to explain that part, it was actually about second normal form.
Okay, thank you very much. So let me explain it by saying this. I think I gave another example to explain. Maybe you didn't capture that one. Second normal form is saying that your table should describe one thing. So if you say the table is student table, it should only describe student. If you say it is this, it should describe that thing. Don't put a table to describe 2 or 3 things. And we're talking about discrete things, discrete variables. And those things are what naturally we order things, how things are structured. I don't think that, Ima, if someone asks you to describe a human being, you will bring in some parts that is not for human being. So let's be specific with your question. If someone asks you to describe a student as yourself, so describe yourself. And if you look at the system we are trying to model, the system has its own discrete parts that comes to form that system. The other time when we were in class, we even tried to understand that by decomposing the school system. And then we had students, we had staff, we had this. If what you are speaking is true, then when you keep the student table and you think residence is not discrete is not separate from the student itself. If you think residence is not separate from the student itself, but is part of the student, then almost every other thing on campus, as long as the student is connected to it, is also part of the student. So the school that the person is in or the faculty is a description of the student. Even the bus that the student boards to class is a description of the student because it's connected to the student. And even the cleaners who sweep the classroom of the student is a description of the student because it has a connection with the student. Even the lecturers who teach the student, all the lecturers, each one is a description of the student because the student has some connection with it. That cannot be. So logically, you should know that if we say this defines a student, you should know what defines it and where the boundary should be placed. That shouldn't be a problem. That shouldn't be a problem. Program is distinct. It's a separate thing from who student actually is. Programs can exist. We can set programs without students being in the school. We can have students in school and there is no program, or there are certain programs that are not yet created because they are different entities. They are discrete variables. Ima, are you okay?
Yeah, I think this one is okay. Thank you.
Okay, so go and read about it further. Any other question?
No, sir.
Yeah, sir.
How would you know? Are you all of them? Kingsley?
Yeah, so sir, with fulfilling the third principles of the first normal form. Sir,
Please come again. I didn't hear you.
I said with fulfilling the third principles of the first normal form, which is there should not be any repeating column. Okay, so assuming we create a table for the column, let's use the phone. For instance, a student can have more than 2 phone numbers. Okay, so
yeah,
after we create the column, a whole table for the phone, and in linking them, is the student ID supposed to serve as a foreign key in the phone table, or is rather the phone table that's supposed to serve as a foreign key in the student table?
Okay, Kingsley, that's a very smart question, but is a premature one. When we get to relationships, stable relationship, now we are trying to get the idea that in relational database system, you will create several tables because each logical component, each discrete thing needs to be stored as a separate table. So you will have several tables depending on the structure and complexity of the system. So we are learning about the principles to follow to structure these many tables. We will later specifically talk about how we link the tables, and inside that lecture, relationship, we'll deal with your issue. All right.
Okay, sir.
Yeah, thank you very much. Any other question? Okay, so this is where we bring our virtual class to a close if you don't have further questions. So we'll catch up later. Maybe face-to-face first before we do some other virtual class. Thank you very much for your time.
Thank you.
Thank you.
Thank you.
Thank you,
sir.
Thank you, sir.
You're welcome.
You're welcome.
Thank you, sir.